Yeah, hopefully you did. If not, ask me a question in the Google Hangout, send me an email. I'm not a fan of the email. Not too bad. Email's okay. It's just a little bit tricky. Sometimes trying to figure out what question you're talking about. It'd be nice if you just came to the Google class and said, Mr. Allen, on this page, what happened here? That's good. Let's do that. Let's do this one. It's a bit tricky. So this one here, so k of x is saying I want to put h into g into f. So f of g of x. So I'm just going to write it in this form, and I'm just going to go step by step. And you want to know, you want to state the restrictions. You want to get the domain of this graph. So the reason I want to go step by step is I want to look at the domain at each step as I go. So here I have h. This is cotangent x squared. Now cotangent, now I should probably remove this question or move it somewhere else, but a cotangent is just another function. It's like a log or something. So that's, it's the reciprocal of tangent, so it's upside down. Okay, we're going to put that into g of x. Now g of x is going to be this. It's going to be 2 cotangent x. Okay, so that's going to look like. So I replaced all the x's in g of x with cotangent squared. That's a cotangent squared. Sorry, there should be a square there. And then I'm going to replace all of that, whatever I got there. I'm going to put that into this log here. So log base 2 of 2 times 2 to the cotangent squared x. There you go. We can probably do a few things with this to simplify this down. I'm going to give myself a little bit of space to talk about the domains as we go across here. But those two things inside the parentheses there, these both have the same base. This 2 is to the power of 1, this 2 is to the power of this. So technically I can add those two together. So it'll be 2 to the power of 1 plus cotangent squared x. That's what that is. And then I can drop that down to the front, 1 plus cotangent squared x. That's going to drop down because that's the exponent on that 2 there. So the exponent rule says I can drop that down. And this is log base 2 of 2, which turns to a 1. So overall, this just turns into 1 plus cotangent, because this is all 1 here. 1 plus cotangent squared x. So we just applied a few rules, and we got down to this simplified form here. That's fine. It looks great. That's the way I probably wanted to end up. But now what is the domain? What are the restrictions on this? Now, we also have probably one more step. I don't have my Math 30-1 formula. I mean, there's probably an identity when we talk about trigonometry later on. There's probably an identity for 1 plus cotangent x squared there. I'm not too worried about that. So what are the restrictions and all of these pieces here? This is a tricky question unless you know what a cotangent is. And then what's the restriction on this last piece right about here? What are the restrictions here? Okay. Actually, in this case, the restriction here. So we're going through all the different simplified forms. I'm not worried about this. I'm worried about the very end. So what are my restrictions? So cotangent x, we haven't talked about this, and I'll probably just talk about it right now. Cotangent x is 1 over tan squared x. Now tan, if you remember what tan is, look up my board up there. You can't see it right there. The tan is opposite over adjacent. Opposite over adjacent. Right, that's what tan is. Technically what tan is sine over cos. Okay? So here cos cannot be 0, but if I do the reciprocal of this, it's going to end up being sine can't be 0. Okay? So sine can't be 0. There's a bunch of angles where sine can be 0, and this is where it gets tricky. Maybe I'll just stop it here and just say this is the answer for this one for now. I'm not too concerned about the domain until we figure out what is 1 over 10, x squared. So this will end up being cos squared x sine squared x. So you got to take the reciprocal of that and square it. That's what this ends up being. And eventually what we're going to have to find out is what would make this equal to 0, because that's not allowed to be 0. If you want to, you can try to figure out what that is. Just take the square root of both sides. The sine inverse of 0, what does that end up being? It ends up being 0. So x can't be 0. But if we'll do this later on. There's a bunch of different answers here. This can't be 0. It can't be 90. No, it can't be 180. It can't be 360. And there's a bunch of other x values it's not allowed to be. Okay? So 0, 180, 360. Because it was what we call a periodic graph. We'll worry about that later. Okay? So we have some restrictions here. X cannot be 0, 180, 360, etc., etc. When we do this with the exponents, when you square this, will always be a positive number, so I'm never going to have a negative exponent. This will always be positive, so I can just put whatever I want into here, as long as it meets this restriction here. So this would probably be XER for now. And this last one here has the same restrictions. Why just my restrictions? Because I have the cotangent x squared there. 0, 180, 360, dot, 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 dot. And we'll deal with that later on. There's all degrees, actually, technically. Sorry, I blubbered a lot about that question, but that question is a little bit beyond what we know right now. But the next 3 questions are not beyond what we know, but they are tricky. Like this one here is pretty tricky because it has lots of different solutions to it, possible solutions, and we just have to know which one of these is the domain of this graph. If I put G or F into G. Okay, so I'm going to write this out. I'm going to put F into G, so I'm going to write G of F. Actually, I'll just write it out what the original question looks like. And then I'm going to put F in here, the square root of x minus 5. Okay, that's what that is. I'm going to look at that. The restriction of this is that x has to be greater than or equal to 5. Okay, so that's going to be useful for later. Then I'm going to put this into G of x, wherever there's an x. So on the top there says x squared, so that's going to be the root of x minus 5. In the bottom it also says x squared, and then a minus 16. Okay, so what I'm going to do is I'm going to simplify this down. I square the top part, I square the bottom part, x minus 5 on the top, and then x minus 21 on the bottom. Then I look at the restrictions of this graph. This graph says x cannot be 21 because of the bottom, right? So this cannot be 0 on the bottom. So 21 would make the bottom equal 0. So I have these 2 restrictions, and I'm going to have to put them together. Because 21 is technically bigger than 5, I'm not allowed that, because if I put 5 into this graph here, sorry, if I put 21 into this graph here, if I put 21 into this graph here, it would pop up something on the bottom here that would make this a 16. And then that 16 minus 16 would end up being 0. So I'm not allowed to have 21 because it's going to have a problem if I follow my steps here. So I have to make sure to include that in my solution. So it'll be 5 here. All right. Remember, I'm allowed to take the square root of 0, so that's just fine. So that's why this is important here. The line. Okay. So that's why you always have to look at the restrictions all the way down. It's not just going to be the last one of just x can't be 20 negative, or the root of 21. Or sorry, x can't be 21, sorry. It won't be just that one. I'll cross that off, right? Because of the other one, it won't be just these ones up here, because the very end has a restriction as well. Okay. Okay, so this one here kind of asks you to figure out what point must lie on g of x. Right. So if I were to put in a point, it says here point A lies on f of x, point A prime, so that's just another point, a different point, with the same x value, lies on h of x. So they're saying that if I put a 2 into h of x, I should get a 10 out. Okay? If I put a 2 into f of x, I should get a 3 out. So let's look at what we have here for my equation. So it says here, g of f of x. Okay, so if I put a 2 in here, so put a 2 here, that means I'm also putting a 2 over here. So that means I know that if I put a 3 in here, so that's what's going to happen. This f of 2 becomes a 3. So that says g of 3. And I know h of 2 is a 10. So it's saying g of 3 is a 10. Oh, so that means if I have an x value of 3, that means I should get a 10 out. That's what happens there. It's kind of a strange little question, kind of reversing the operations, what we usually do. But eventually just works itself out. It's nice. That's a really big blank space there for that page. Probably because this question is really big. Okay. Now, the fun thing about this question is a very similar kind of question what we did before. I want to know what are my restrictions and possible domains for doing these operations. So let's start off with the easy ones, g and h. When you divide them or minus them. Those seem like the pretty easy ones. So the g, which one's g? G is this quadratic here. G is a quadratic, so that's XER. And h is this kind of radical looking graph where x has to be greater than or equal to negative b. Okay, so these together is just saying that it has to be greater than or equal to negative b. So I'm going to say my reference for it. That is going to be 1. This one here, let's see, my g of x again, that's just going to be XER. And the bottom graph here is this h of x again. Ooh. The bottom graph is x has to be greater than or equal to negative b, but it's on the bottom, so that's going to cause problems when this y values are 0. If this y value is 0, I'm going to divide by 0 error, so this can't be 0 on the bottom. So that is when it's equal to negative b, so that's why this is a 2. So you notice that this doesn't include negative b. Because if it was negative b, that would pop up a 0, and I'd be dividing by 0. So that's why this is a 2 down here. Okay? That's a really messy solution there. Okay. Now the harder one here is trying to figure out what is g of x for this one. Now, I want possible domain restrictions here. So it's going to be kind of a tricky thing to do, but I'm putting g into f into h. Okay. So I'm going to go, let's just look at step by step what we're going to do here. Oh, sorry, that was a beep. I just have to go double check that. I'll be right back. All right, so for this last function, for operation A here, it's going to get a little bit tricky. And let's just finish this off here. It gets tricky because we don't know what A and B are. We could just make up numbers and then see if that works. We could just say, for the sake of argument, let's see what happens if A was equal to 1 and B was equal to 2. Right? We could do that and then kind of look at this equation. If you want to, you can also maybe create some of these equations, like this quadratic over here. Kind of looks like it could be x plus 1 and then x minus 2. That looks pretty good. This little root graph kind of looks like it could be x plus 2 because it looks like it got shifted over 2 units. And this graph here, this is a log graph. It has a vertical asymptote. It has that, turn your head sideways, it looks like a decay graph. This is probably going to be the log of x minus a. You see that's the reason I put a minus there is because it's moved over a units. This one here is moved over b units that direction. So I'm going to put minus a. You can graph. So let's just say that's what it is. Oh, a here rather than a. We decided a was 1. Okay. Okay. So let's use that just for the sake of argument and just see at the end, do we get any of these values? And what you're going to realize is that none of these are going to work for this. This question is all over the map here. It's a fun question. It's a hard question. You probably will never be asked this kind of question. I will ask this kind of question. It's just a little too difficult at this point. But what we can do here, let's just go through here and just label off certain things. Okay. So here we have a quadratic. I'm just going to multiply this quadratic out. It's x squared minus x minus 2. Okay, so I just multiply that out. X squared minus x minus 2. Bracket, bracket. Okay. So right now, there's no restrictions on that. This is a quadratic. That's fine. I'm allowed to have that. Then I'm going to put that into f. Okay, so let's put that into f here. Let's put that into f. Oops, sorry. F is a log function, so that's going to be log of x squared minus x minus 2 minus 1. Okay, let's put that there. Let's simplify that down a little bit. X squared minus x minus 3. Now the thing about log graphs, you notice that in the log graph, there's nothing over here, right? Because I'm not allowed to take the log of a negative number. So this, whatever's inside the brackets here, has to be greater than 0. All of that has to be greater than 0. So I have to look at that and say, okay, when would this graph be greater than 0? Well, first of all, I got to figure out when it's actually equal to 0. I'm not going to be able to do the, I'm not allowed to factor this. Nothing multiplies up to 3, and that's a negative 1. So that's not going to work. So I'm going to use the quadratic formula to solve this. I have the quadratic formula right there. I don't know if you can see it. It's pictured as minus b, so negative b. So that's negative negative 1, so that's positive 1, plus or minus the square root of b squared, which is 1 squared, so that's 1, minus 4 times a times c, all over 2a. So that's 2 times 1. Okay, so I got 1 plus or minus the square root of, just punch in my calculator here, don't know why, 13 over 2. Okay, so these numbers are not very nice here. We could put in some things in here, but what we know about these two values, because this quadratic is opening upwards, this one we just created here. I'm worried about this point over here because that makes this a positive value, and this point back because that's also positive. Everything down here is negative, and I don't like that. It's bad because you can't take the log of a negative graph. So my restrictions on the domain of this graph, the log graph part, this piece right here, is x has to be greater than whatever value this x value is over here, which would be 1 plus the root of 13 over 2. And x has to be less than, now it's not equal to, because remember you can't take the log of 0 either because there's an asymptote there. So it has to make sure this is greater than 0. So it has to be less than 1 minus root 13 over 2. So those are actual numbers. You can put them in the calculator and get some decimals there. But none of those numbers match any of this stuff over here. So right now we have a restriction that has to be XER, and we have a restriction that has to be these two things here. Oops, kind of crossed that 2 out by accident there. Okay. Right now this is our main, this is the bottom part is our restriction here. Okay, so now what we're going to do is we're going to create our next equation. So we're going to put this into h. So h is the square root. So the square root of all of this. That's the square root of all that. Oh, and plus 2. Plus 2. Okay, so what this is saying now, so this is the next step. So our next step here, this is saying that for this to work, all of this that's underneath here has to be greater than or equal to 0. So it's saying that log of whatever we just created here plus 2 has to be greater than or equal to 0. Okay, how is this going to work? So x plus that has to be greater than 2. So what do we have here? To make this greater than or equal to 0. So first of all, let's look at this here. I want to know when this log is greater than -2. Okay, so I'm going to change this around to do it maybe into an exponential function here. So I'm going to change this into exponential function to find out when is this actually equal to -2. So this be 10 to the power of -2 is equal to x squared minus this, 3. 10 to the -2 is our small decimal. This is going to be a pretty ugly answer here. This is 1 over 100, so that. And then I'm going to subtract that number over to the other side. Holy moly. And I'm going to get 3.01. Okay. What I'm going to do now is I'm going to use the quadratic formula again, solve for new restrictions on x, and then try to figure out, okay, what does that mean? Do I have to be greater than those values or less than those values to make sure that this is greater than 0? So you have to make sure that this is greater than -2 to make sure that this is greater than 0. There's a lot of stuff. What happens, it becomes really ugly. So I've got, none of the answers up here work. So this is just garbage over here. So what I'm going to do is I'm going to show you what this looks like in Desmos. Okay. So Desmos is an awesome resource here. I'm just going to turn all these graphs on. Okay. Turn off certain graphs here. So these are the 3 graphs we started off with. We've got the quadratic. I called that, you can see over here, I called that g of x. We got the root graph. I called that, what did I call that? H of x, just like in the question. And then we got the log graph here. I decided to use log base 10. And you can see I called it f of x. These graphs pretty much match the graphs in this question up here. Pretty closely match. Oh, I don't want that one. I want the Desmos. Okay. So my log graph looks pretty good. And they both, you notice that they both go through B. This one goes through B, and this one over here goes through B. Over here, they both go through B as well. So that's pretty good. Yeah, it looks pretty close to what they should be. Maybe this one's going a bit too low. I'm not too really concerned. I don't know what my actual scale here is. But you notice that this one's going through. Yeah, maybe it's a bit low on this one. So maybe I'll change this, kind of squish it in a bit. Maybe I'll change it to a half. Let's see what that looks like. That looks a bit better. I kind of wanted to match the scale on this one here. You can see that the quadratic x-intercept is like, looks like a -a. So I want that to kind of be a -a as well. If my a is -1, or my a is 1, sorry, it's -1. Okay, everything else looks pretty good. Can't really tell about any of the parts of this graph though. Yeah. Yeah, it looks pretty good. Okay, so we're going to put them into each other. So the first thing I'm going to do is I want to see what happens when I put G into F. We had this one over here. So G, being the red graph, I'm going to put that into F, the log graph. So I had that over here. I'm just going to check it off. So I put G into F. You can see where I label it K. So that's what this graph is going to look like here. Well, my thing's in the way here. Do I want to stop my video by accident? Oh, did I break my computer? Yeah, I might have. Oh, I did enter up there. Okay, sorry. I didn't break my computer. Did I? For some reason, I can't start my graph. Okay, so I'm just going to create a new graph here. Let's call it K of X. Oh, I need to capitalize. Maybe that's why. K of X. And I'm going to put, what I was going to put? I was going to put G into F. Okay. So that's what that one looks like. And you remember what I had before is that we had these weird values down here. You can kind of see them on the bottom of the screen here. These X values, you can kind of see the same X values that are here. So you got these vertical lines here. I could probably get rid of the previous graphs here. Oh, I can't unselect them for some reason. They won't let me do it. kind of broke my computer a little bit. So that's what that one looks like. So yeah, okay, that's what I kind of expected. We need some x values greater than some value, x values less than some value. The value is just slightly more than 2 on this side over here. I can just double check that. What is, oh, it's going to be slightly different because I changed my A value here, but it's going to be slightly bigger. But it's not B or A. That's okay. And then what I'm going to do is I'm going to put that graph into H. So I can just do it this way. That's that purple graph there. It's kind of bold. So that's what that graph is. And you notice that's not even close to B or A. It's this kind of weird shape to it. Kind of what we expected. We used the quadratic formula on the last piece. You would get something similar to the one above it, similar to this one here, right? Slightly different because one has an extra 0.01 to it. Whew. Now, I'm never going to ask a question like that where you put a function to a function to a function and determine the domain. I could ask like this question here, but I have two things, I put them into each other, pretty simple to easy to determine what the domains are, pretty nice numbers, and it gives you multiple choice there. I could ask you this one, that's a pretty nice question. I can ask you like B and C here, so these two things I would probably legitimately could ask you, but this here, way too hard. It's possible, it's way too hard. I know I kind of blubbered a lot on this video. You probably could have stopped it at any point, unless you just like listening to my voice. That's kind of weird. But that ends off this chapter, ends off this unit. Work on the assignment for this chapter. I'll probably make some kind of pre-test or some assessment here that you could practice for the actual test that we're going to be doing. Okay, I'll see you in the next video. Ciao.